Today we're going to learn about exponent rules. There are three general exponent rules, which are negative exponents, product rule, quotient rule, and power rule. Today we will be learning about the first three, which are negative exponents, product rule, and quotient rule. So to start out, we're going to talk about negative exponents. Negative exponents are bad unless we are dealing with scientific notation. So we do not want negative exponents when we are simplifying an expression. So to do this, if our negative exponent is in the numerator, so we just want to look at this as being a to the negative n all over 1. We just need to flip these. So it becomes 1 over a to the n. This can also be written at, or another way to look at this is also 1 over a to the negative n. And this will become just a to the n. So let's look at a few examples here. So x to the negative 5, we can also write that as x to the negative 5 over 1. So this is going to equal 1 over x to the 5th. So we're just flipping this. 3 to the negative 3rd, we can look at this as all over 1. So this will also equal 1 over 3 to the 3rd, which simplifies to 1 over 27. 8 to the negative 1, we simplify that, and that simplifies to 1 over 8. 5 to the negative 2, sorry about that, this becomes 1 over 5 squared, which also equals 1 over 25. And one more example that I had you guys add to your notes was 1 over 2 to the negative 3rd. So we have the negative exponent in the bottom. So this becomes 2 to the 3rd, which also equals 8. Now we want to talk about any number to the 0 power. Any number raised to the 0 power is always 1. This is because when we write out all of these here, we will see that when we divide by 2, we will get that when we divide by 2 here, we get 4 divided by 2 is 2. When we divide by 2 again, we'll see that this becomes 1. And if we divide by 2 again, we get 1/2. Divide by 2 again, you get 1/4. You can also start here and multiply this by 2 to get this, and multiply this by 2 to get 1, and you'll see that any number raised to the 0 power is 1. So the product rule, what does product mean? Product means multiply. So we are taking two numbers with the same base, their base here is a, and we're multiplying them together, and we will see that their exponents are added. So here our base is 4. So we have 4 to the 3 plus 2. So this equals 4 to the 5th, which equals 1024. In this example here, we have our base, which is 3. So we have 3 to the 5th plus negative 8. This equals 3 to the negative 3rd. So we need to get rid of this negative exponent, because remember, we do not like negative exponents. So this becomes 1 over 3 to the 3rd, which equals 1 over 27. Our base here is y, so we need to take y to the negative 3 plus 6. Remember, product rule, we need to add our exponents. And this becomes y to the third. Now, in this example here, our base is x because our exponents go with the x. So the 2's are just coefficients. So we need to multiply coefficients together. So 2 times 2 is 4. And then add our exponents. So 6 plus 3. So this equals 4x to the ninth. Once again, we have coefficients out in front, so we need to multiply our coefficients, which 6 times 6 is 36, then add our exponents, so r to the 2 plus 5, so this equals 36 r to the 7th. So now here we have 5 to the 0 power. Remember we said anything to the 0 power is always 1. So we can just cross this out, and we're left with 5 squared, which equals 25. We can also look at this as being 5 to the 0 plus 2, which equals 5 squared, which equals 25. So now we're on to the quotient rule. What does quotient mean? Quotient means we are dividing. So once again, we have the same base here, same base number, and when we divide it, we get the top minus the bottom, so m minus n. And then if we have negative exponents, we need to move those appropriately. So remember, we do not like negative exponents. So here we have z to the 6 over z to the second. So we get z to the 6 minus 2, which equals z to the 4th. You can also look at this as z times z times z times z times z times z all over z times z. You see that these cancel out and you're left with 4 z's here. So this equals z to the 4th. This one here, we have negative exponents, but let's go ahead and do the quotient rule first before we mess with any negative exponents. So always do the rule first before you mess with negative exponents. So we get x to the negative 2 minus negative 3. This becomes a plus 3 because 2 negatives make a positive, which just equals x. And this one here, we have 3 to the 4 minus 6, which equals 3 to the negative 2. Remember, we don't like negative exponents, so we need to flip it. So we get 1 over 3 squared, which equals 1/9. So for this one here, we have a coefficient out in front. So we're going to take care of our coefficient. So we want to divide 6 by 2. So we get 6 divided by 2, which equals 3. And we have our y's left over. So y to the 6 minus 5. So our final answer is going to be 3y, because 6 minus 5 equals 1. Alright, once again we have coefficients, so let's take care of our coefficients. 5 divided by 5 is going to be 1. Now let's look at our exponents. We have r squared and r to the 0. So r squared minus 0, which equals r squared. You can also look at it as r to the 0 being 1, so you would not need that. So you're left with an r squared. And for this one here, we have coefficients once again. So 32 over 8 simplifies to 4. Then we're left with x to the 20 minus 23. So this equals 4x to the negative 3, which simplifies, which remember we don't like, or negative exponents, so we won't simplify it yet. And we get 4 over x cubed. Remember, you only take the variable and its exponent. Do not take the coefficient. Alright, so here's some more examples. So once again, we want to multiply our coefficients together. Now I'm going to take care of the y's first because I see them first. So y, so we have negative 1 plus 2 because this is product rule. Negative 1 plus 2 is 1. And then we are left with x to the 4th because there is no other x's. Here we have coefficients of 3, so we want to multiply 3 times 3, which becomes 9. And our y's, we have y to the 1st and y to the 4th, so 1 plus 4 is 5. We have x to the 3rd and x to the 0, so 3 plus 0 is 3. And z to the negative 1. Remember, we don't like negative exponents, so we need to rewrite this without any negative exponents. We get y to the 9y to the 5th, x to the 3rd, all over z. Here we see that our coefficients do not simplify at all. 3 over 4 does not simplify, so we can leave 3 over 4 as it is. And we have negative 1 minus 0. Remember, this just becomes 1. So we have 1 times 4, which is 4. So then we have our negative exponent in the top, which means we just need to take it to the bottom. So we get a final answer of 3 over 4x. Once again, we have coefficients that will not simplify, 3 over 2. So you want to leave that the way it is. And we have no other x's, so the x's stay on the top. And we have negative 2 minus, we have a negative 2 minus 1, which equals negative 3. So we need to get rid of that negative exponent, so we get 3x cubed all over 2y to the 3rd. Alright, now our last two examples here, we want to take care of the product rule first. So we're going to take care of the numerator in this problem first. So we can take 3 times 4, which is 12. We have x squared and x to the 0, so that just stays as x squared. Our y's, so we have 5 plus 3, which becomes 8. And we have z to the 1st. I'll just rewrite the denominator here. So we have coefficients, so now this is just like a simple quotient rule one. So we have coefficients here, so 12 divided by 6 is 2. X squared minus x to the 4th, so we have 2 minus 4, which is a negative 2. 8 minus 1, 7. And 1 minus 4 is negative 3. Once again, we need to take care of our negative exponents. Move those to the bottom. And there's our final answer. Last example here. So once again, take care of our product rule first. So we have 2 r to the negative 3 and 0, so that's negative 3. S squared and s to the 5th is going to be s to the 7th and t to the 4th. So now we just need to rewrite this up here.